Hello, everyone, and welcome to the information session on Introduction to Electronics, Electrical, and Digital Circuits. Uh, the key objective behind designing this course is to give individuals, a kind of a basic overview on these very important technologies and which can potentially lead them to decide whether they want to further pursue their career onto these one of these technologies discussed in this course. So normally it's expected that students have completed their high school diploma and they're entering to colleges, universities, or private colleges for their undergrad um, diplomas or degree. So we expect students to have a decent knowledge of mathematics and physics in relating to this course. So let's get started. So it's important that whenever you are studying any particular topic, to pay attention to the keywords. So in this particular slide, as you can see, um, the technical keywords are electronics, electrical, and digital. Also circuits. So circuits is basically the way when you connect components together to achieve a certain objective. So that's what the term circuit stands for. But going back in the history of electronics, electrical, or digital keywords, it's a big topic in itself. So what I have done, if you um, go to these links, if you click on these links, which is basically the link is to this particular slides are given in the description. So if you click on these links, it will take you to the history of these important keywords, and you can understand when this keyword started and associated information relating to that. So as you can see, it's already mentioned here that anyone interested, kindly click on each word below for the meanings and origins. So we have planned to start an institute. We will name it as Quantech Field Institute, and under Soft Galaxy Technology Inc. is primarily is the current company we work under, um, and so so the idea behind these particular and the series of courses, a similar series of courses, is to give individuals an openness or basically an open environment to not only to learn but to acquire hands-on skills. So the emphasis is basically is uh, giving hands-on skills. So you will be tested rigorously in person. So uh, wherever you are in the world, if you are interested in taking any of the course which we are offering, just simply send us an email, info at HS Clouds. HS stands for Humanity Serving Clouds.org or softgalaxy.hsclouds at gmail.com. So basically, it's is to serve the humanity, and such courses are offered at no cost if you cannot afford, but you have to justify that is the case, and we will properly take care of your application and give this education for free. But for individuals who can afford, you have to pay the dues required in order to complete the course. What we believe in, that there is no shortcut to glory. So there is no quick learning. You have to practice. You can get a high level understanding quickly, but to really have a good grasp on any field, any topic, any learning discipline you choose, you have to work, and you have to work intelligently and hard in order to prove yourself that you have enough information, you have enough knowledge, hands-on skills that you can excel or take care of the job responsibilities assigned to you. So that's why it's one of the sentences we truly believe in. Okay, and that is the currently Soft Galaxy Technologies Inc. We don't have a website because we don't have a. Maybe in future we will, but the main focus is on the LinkedIn Professional website, which is very well recognized. And anyone interested in looking into what we do or what we have done for helping organizations, you can go to this website and find that out. Before moving to the next slide, so how, for example, if you're interested in taking the course, send us an email, and then how you will be tested. Let's discuss this during this presentation, and we will share the details. So let's carry on. So by taking this particular course, you can opt for following careers. You can be an electronics repair technician, but just having this introductory lesson might not be enough. You have to not only complete the course, but you have to practice a lot in order to acquire hands-on skills in order to be able to perform the jobs as an electronics repair technician. You can be a basic electronics designer, even though you may need to take additional courses in relating to do such kind of a work. You can be a firmware developer. Firmware developer is primarily a programmer which has the ability to program microcontrollers, microprocessors, or DSPs. We will primarily, again, additional courses are required for you to take in order to acquire these skills. Our focus will be in other courses to work with Arduino, Raspberry Pi, and similarly very well known off-the-shelf boards and popular, well established, in order to give the required skills to our students in order to be able to prove themselves that you can be a firmware developer. We will also share basic knowledge of on electricity. Again, as Raid mentioned in the beginning, that you might, among the three disciplines of being electronics, electrical, and digital, we give you a high-level understanding, and you can opt that which particular area of is more interest to you in deciding your career options. So here are the course objectives, which are already been mentioned, but let's go through this slide. Understand basic working principles of electronic components. Understand basic working principles of digital components. Understand and build basic electronic and digital circuits. And introduction to electricity and microcontrollers. Seeing is believing, so that's where some of the links are here. So I would like you to see that what these particular three keywords have achieved so far in serving humanity. So let's look into this particular video, and it's a Samsung Galaxy factory tour. And showing that how phones are made. So if you look into that, I greatly appreciate. Do not skip the video because it will give you a very good overview of what you will learn. So this is the factory which basically is using the technologies of the three keywords of electronics, electrical, and digital in order to make a cell phone we use in our daily lives. So the idea behind showing you these videos is to inspire you that if you pursue any of these three particular keywords, what kind of knowledge you can acquire and what you can acquire the skills um, in order to have a successful career in your life. So you see these are robotic arms, so you can design robots. Again, it's quite very interesting area in itself, requiring a lot of knowledge, engineering skills before you can do that. So this is cell phone testing, assembling, testing, as you can see here. Very well said. Best technology will always improve your life, and that's exactly the idea behind innovation, research. So what you just saw were the PCBs. That stands for printed circuit boards, which is basically the electronic. Yeah, these are all PCBs, which goes into in this particular video as Samsung Galaxy phone, but in other electronics and any electronics smart gadgets you see, it basically comprise of PCBs, printed circuit boards, and that is the kind of the job of related to the three keywords this course is going to give you in production now, which is electronics, electrical, and digital. CNC is a mechanical engineering job. We are not going to discuss mechanics in this particular, but mechanical engineers, electrical, electronic, and digital engineers work together very closely in order to bring the final product. So this is the PCBs you just saw. This is the automated assembling of the phone, packaging, and shipment. That's what you just saw in the Samsung Galaxy factory tour. So let's go back to our slides and let's look into this robots. The robots is a very popular keyword globally, and we are going to see that how the robots are used in industry. So this is basically a Tesla manufacturing plant, and these are robotic arms. You can see they are used, not only in car assembly factories, but they are also used heavily in many other industrial areas. Robotic arms, uh, like the robotic arms, are also used in medical. Um, uh, you know, Surgical operations or so on and so forth. So this is again, as I said, it's a very very important keyword like robotics, very popular, among public globally. So as you can see, this Tesla factory robotic hand is lifting the car from point A to point B in order to achieve the desired functionalities in completing the manufacturing of the Tesla cars. Okay, so let's move to the next link, and let's look into these self-driving cars. Again, in the Western world, it's also kind of a popular uh, known area where uh, people are paying attention to that how this technology work. So this in this particular video, this is a pizza shop. They have received an order through their whatever app or ordering system, and the business is here's a self-driving car. He punching in the keyword or whatever ID required. He placed in the order to be delivered to the customer. And here you go, the order is placed, and this self-driving car, like, there is no driver. Uh, as you can see, it's pretty tiny, so obviously there is no driver, but also there is no remote controlling of this particular vehicle as well. So it's self-driven. It's going to the destination of customer. In some cases, there is a remote human able to communicate with the customers, but not in this particular case. So it's going to the customer destination. It has a lot of sensors, a lot of technologies goes into making a product like that, which is basically a self-driving car. And but whatever it's using, it's all relating to three technologies, which is electrical, electronics, and digital. Here you go. Here's the customer. The vehicle stops. The customer picks up the order, and here you go. So as you can see, it's quite fascinating that how technology can be used in serving humanity, and in a very safe, reliable, and in a quality manner. And so I'm just going to go a bit. So it's primarily, as you can see, it's just going to come back. So let's move on to our next link. And this is primarily the orders fulfillment, Amazon's order fulfillment center. And Amazon, as you all know, is the globally very well recognized, one of the largest online retailer. And in this particular video, it shows that once the order is received, how it fulfills. They have built their own kind of a system, the software system, the software architecture, which basically receives the orders, fulfills the orders, and they used robots heavily on the ground, in the air, in order to win customers' confidence in basically what is customers' confidence that once they place through Amazon, they will receive as they promise. whatever they have placed using their online system, which is amazing. So they also use, as you can see, self-driving robots like this for delivery. They also use drones, to deliver packages to customer destinations. There you go. The drones picking up the order from the business side and delivering it to the customer, and that's their system which they have built in order to achieve quality, their overall ordering system. So there you go, the drones comes to the customer site. There you go, that's amazing. So as you can see, let's show some of the other um, so it's showing drones all the way, and also let me show you this airship. They can use, and they are basically prototyping that airship delivery, to the remote areas where it's very difficult to go by land or other means. So airships can really help them achieve in serving humans at remote locations. So I think that is kind of enough introductory videos in relating to just trying to inspire you and show that what you can basically achieve if you opt to go into these particular um, industrial segments. So let's continue on with our slides. So in this particular course, Introduction to Electronics, Electrical and Digital Systems, there will be a lab component and a very rigorous lab component, because as mentioned right in the beginning, we want you to have hands-on skills, and to achieve hands-on skills, lab is mandatory, essential, a quality requirement for the completion of this particular course. Um, so you're required to have resistors of these values, capacitors of these ratings, diodes, conventional low power diodes, um, LEDs, red, green, blue. Um, we are not going to practice with inductors, but because if you're ordering a kit, it's good to have some inductors as well, which can help you with other courses as well. Transistors, NP and PNP transistors, low power transistors are required, is a requirement to be part of this the lab work. ICs, basic digital ICs like inverters, 74LS04, NAND, NOR. So basic digital ICs are a requirement for the lab work. Multimeter must be, in your gadget. A small breadboard is also, because that's what can help you. Breadboards and wires for the breadboard can help you do complete the lab work, okay, without soldering or using a soldering iron. But we do recommend you to order a soldering station as well for your site, because acquiring a soldering skill will be really, really helpful if you do decide to pursue on this particular um, career as an objective. Power supplies, not a huge complex power supply, but let's say a 5 volt or a 12 volt power supply is a requirement for completing the lab work. Digital oscilloscopes or a low cost oscilloscope or any oscilloscope you have at your site or in your gadgets is also kind of a good to have tool in your gadgets. And so some of the resources which we will recommend as we go along for basic electricity experiments, and some old PCBs working or not working, good to have in your lab setup or in your lab environment, whatever you opt to do, or if we are taking care of all that, so you can expect all these equipment in the lab, which you will be working with and acquiring knowledge and hands-on skills, uh, you know, to be confident doing experiments, lab work, and doing things by yourself. Let's carry on. So in this particular slide, it shows the basic electronic components. So as we go along, we will discuss in detail. But just as in it's a scale showing that how big the components can be, and so these are capacitors, relay, some of the transistors, some ICs. These are the diodes. We will discuss as we go along. These are transistors as well. These are LEDs. So we will discuss. These are SMD devices. SMD capacitor. We will discuss in detail as we learn about these components. Okay, so you're expected to learn about the components and how to use these components in building basic circuits, and that is the focus of this particular course. Let's carry on. Yeah, so in this particular course, so here's the marks distribution. 10% are the assignments, and the assignment will be given to you as 5% before the midterm and 5% before the final. And remember, all the lab work which you will do, it will be part of the assignment. So there will be one lab every week or every 2 weeks, depending on how we are progressing. And there will be assignments given to you during these video lectures, and it's expected that you will submit as advised. And lecture assignments, book assignments, or any assignments given to you during video lectures, plus the lab work, that two things together constitutes 10% of the markings. So the question is how we are going to really test you on the lab work. So that's why the lab work is given 20% weightage, and how you will be tested. We will it will be it will be an in-person exam, and we will schedule it on your location. Basically, it can be a town or a city, wherever it is, and we do recommend and ask you to recommend few businesses like a library or a government or a private institute where you can go and take an in-person exam. It will be You will be connected using Zoom or other ways, so that we can monitor you remotely. The way we want that exam to be conducted, and there will be on-site monitoring by the local arrangement. If you do, or if you can't do it, just let us know, and we will make arrangements that where you have to show up in order to take your lab exam, midterm, or final in person. Okay, so we will be, as I mentioned, we will be monitoring and making sure that it's an ethical environment, and you will be tested as we want you to test to make sure that you acquired the skill taught in this particular course. Okay, so what will happen that let's say you show up for the midterm. So before the midterm, there will be a 1 hour exam for the lab work, which will be on the midterm. It will be 10% of the weightage, and on the final, it will be the rest of the 10%. So before the midterm or final, you have a lab exam. We will give you assignments to be completed in 1 hour, and then we will give you a half an hour, 1 hour break before we will test you on the midterm day, or for the final on the final day. So that's how we are going to make sure it will be ethically tests done in order to test your hands-on skills, your knowledge, and the minimum marks required to pass this course or any of the relevant courses will be 50%. So you have to score more than 50% before we can issue you a certificate of completion from the institute. Okay. Along with this, there will be 4 industrial tours, business field trips, which is in line with the course objectives. And we encourage all students to be part of these industrial field trips. If you are, somewhere in the globe, and so we can work with you in order to see that how these field trips can be completed. For example, if you're living in a town or a city where there is not much industry, so what we can do, we can either have live kind of tours where you be part of it. We can help you be part of these industrial tours, or we can have pre-recorded videos for you to see and be part of those industrial tours. The entire idea behind the industrial tours is so that you can have real experience that what you're learning and how those learning is applied in the industry, and the people working, the kind of jobs in relating to electronics, electrical, and digital circuits or systems. So let's carry on. So we will introduce you. So let's in these basic electronic components, it's showing in detail, the symbol of an electronic component and the name of it. So this is a symbol of our diode, capacitor, inductor, resistors, a DC voltage source. DC stands for direct current. This is a symbol for AC. AC stands for alternating current. Why alternating? Because it's varying with respect to time. So if this is the x-axis and this x-axis shows time, so with respect to time, as you can see, the amplitude of this voltage is changing. So that's why this symbol, by just looking into the symbol, you can see that it's an AC voltage source. Where in case of DC, with respect to time, it's a straight line. So that's why it's called direct current voltage source. Okay. So these are the logic gate symbols when we talk about digital circuits: AND, NAND, OR, NOR, exclusive OR, and a NOT. So in all these, when you look into those digital symbols, the important thing that you see these bubbles. You see this bubble here, this bubble, and this bubble. Remember that this bubble in digital circuits or symbols means NOT gate, NOT operation. And these bubbles can show up as a basic gate. They will show like this, but when you look into the ICs stands for integrated circuits. These bubbles can be in any of the inputs. It can be here, it can be here, or it can show up at the output as well. But just as an introduction, as you can see, the gate is the same, but they are differentiated by the bubble. Same gates, bubble. That's why the NOR. So it's basically AND gate and an inverter in the end. It's an OR gate, but with an inverter in the end to make it a NOR gate. Exclusive OR gate is another special kind of a gate, and there is another gate is called with the bubble in it is called exclusive NOR. We'll learn about it in detail as we go further in this particular course. These are the symbols of capacitors. Capacitor can be of two types. Unpolarized. In unpolarized capacitor means it doesn't have a polarity. It means that you can connect either way in the circuit. So it doesn't have plus and minus. So it's unpolarized. And normally an unpolarized capacitor, when you see it and hold it in your hand, the size of the legs is the same. So, but just holding the capacitor, you can tell is whether it's polarized or unpolarized. The symbol is like this, but with a polarized capacitor, normally it can be like this, but the other side can be a curved line rather than a straight line. It can be like a curved line. If I want to show you, let me draw it myself. Hold on. Okay, just give me a minute. So it can be in the polarized case, it can be a line like this, and this will be the positive side and this will be the negative side. Okay, so that's what I was trying to show you. And when you physically hold the capacitor, the leg which will be longer in length will be the positive side, and the shorter leg will be shorter in length will be the negative side. And it does some of the capacitors do show you on their body as well. As you can see, this negative sign, printed on the body, showing you which side is negative. Because sometimes when they are pre-cut to equal size for whatever reason, the symbol on the body, this really help you find out where the negative is. So this is the symbol of the diode. The positive side is, as you can see, this is like a triangle. With the positive side, the line is the negative side. When you physically hold it, you will see this, as you can see, this white notch or a white strip. So the white strip side is the negative side. The rest of the, which is the larger body area, is black. So that will be the positive side of the diode. This is the LED. LED is just like a diode. Similarly, everything's same, except that it shows that because it glows, and you can see light coming out of it. So that's why the two arrows, and it's called LED. LED stands for a light emitting diode. It's expected that whatever information giving in these sessions, you note it down using your notebook and a pen or pencil, and you can be tested during exams to make sure that you understand all these important terminologies. Again, as one of the longer length leg is plus and the shorter one is negative. Components, electronic components having legs are also called axial components. In comparison to the other type of components, which we will discuss in coming slides, are called SMDs, which doesn't have leg like this, but those have edges. We will see how it looks. This is a symbol of an optocoupler. So optocoupler is comprised of a diode, as you can see, the symbol is the same, and a transistor, which is the symbol right here. We'll discuss further on in our upcoming slides, information sessions. So this is the symbol of an optocoupler. This is a photoresistor. So wherever the term, wherever you see the word photo, it means light. Resistor. So a resistor which varies by the amount of light is called photoresistor. So the symbol is this is the symbol of the resistor, which is a simple resistor. But a photoresistor has this arrow sign which changes, which means that it can vary its resistance based on the amount of light it receives. So it's called photoresistor. It's a part in short, but in completion, called potentiometer. It has a knob. So this resistor, you can change the resistor by changing the knob. And this is a symbol of a relay. That's how it looks physically, and this is the symbol. This is the resistor symbol and how it looks. We will go further detail into this particular, that how to read the values. And again, this is an axial resistor, axial capacitor, axial diode, axial LED. This is the symbol of a stepper motor, and as you can see here, this is the symbol of a switch. It's basically a contact point. When you press, this contact closes, and we will discuss the type of switches can be, but this is one of the simplest switch, single pole, single throw. So this is your pole. When you press, it closes. It means it throws this as on and off. As discussed before, it is the symbol of a transistor. Okay, let's move on. Okay, so let's learn about the resistor, and this is the basic symbol of the resistor. So what is the resistor? A circuit element, which is we call it as a resistor. Obstructing means is causing a resistance, and normally we will show the resistance as an R. So a circuit element obstructing flow of current in the circuit is called resistor. You don't have to memorize this particular definition, because you can describe a component or a technology or a feature in many other ways. So anything which causes resistance to flow of current is a resistor. The term opposite of resistance is called conductance. We represent this by G and related to each other as shown in the equation. Again, this is all basic mathematics. By just looking at this equation, as you can see, that the resistance is inversely proportional to conductance. This is 1 divided by G. So it means if the conductance goes up, the resistance goes high or low. Right, the resistance will go low because it's inversely proportional. And for example, if we say that the variable A is directly proportional to a variable B, what it means? If the B goes up, what will happen to A? Right. So the A will also increase. If B is increasing, and so the A will increase, that means these two terms are directly proportional. And if A is inversely proportional to the B, it means if A is increasing, the B will decrease. Or if the B will increase, the A will decrease. Either way. So that's exactly what the term, the relationship between resistance and conductance is, that they are inversely proportional. You can write it like this, or again as a simple method, you can rearrange, as you know, simply by this. So in this particular figure, it's showing you the fixed resistors of different sizes and shapes. As you can see, the resistor doesn't come like any other product. It comes in different shapes and sizes. Similarly, these are variable resistors, pots, potentiometer. You can find it from stores online or in person. Whenever you order a product like this, they look like this. And these are the SMDs type of resistor. They are not axial, just like these ones. They have legs. In these ones, why they are called SMDs? Because they are surface mounted devices. They have edges, conductive edges. So you just place it on the surface of the printed circuit board, PCB, and they connect with the solder, and provide the required functionality. These resistors come in different sizes, as you can see, but the most commonly used sizes are shown here. It's not the value of the resistor, it shows the size of the resistor. 0603, 0805, 1206, and we will discuss later what, how to read these sizes. Okay, just carry on. So this is a basic circuit shown, which shows a load connected with a battery, and this is, as you can see, already that how the battery symbol look like. A battery means it's a difference of potential. If you know potential energy, as you go high up from the ground, your potential energy increases. So in the electrical world, that's exactly what it means. It's not going high as a position, but it's internally because of the difference in energy so stored at one point to the other. That's why the difference of potential, which gives us the voltage and the flow of electrons. And the flow of electrons can happen plus to negative, or it can go negative to plus. Either way you can consider, and both are fine. We will discuss how the current flows in one of our upcoming slides. So electrons flow in a circuit because of the difference of potential. So that is the reason. That's why when we throw the ball up, it comes down obviously because of gravity, but it's easy to understand that as it goes up and up in air, its potential energy increases and it comes back because of gravity and difference of potential with respect to ground. So what is the difference of potential? Measure voltage across any battery using voltmeter. So if you have the voltmeter and let's say at home you have a AA size, AAA size, or A size batteries, or any battery, you just use your voltmeter, and if you know how to use your voltmeter, then just connect the positive lead to the positive side of the battery, which is normally in AA or AAA size battery is the notch coming out of one of the edges. That is the positive side, and the flat side of the AA or AAA size batteries or A size battery is the negative side. So if you connect it, and you can read the voltage of that battery. In a 9-volt battery case, if you have that battery, then it has two circles on the top. The bigger circle is the negative side, and the smaller circle is the positive side. If you don't know how to measure the voltage, don't worry, we will cover it up, how to use a voltmeter in order to do this. Okay. So what is a load? The circuit point where current returns to its source. So as you can see here, we have a load, and the current is flowing, in this case, plus to negative. So this is basically a point. If there is no load, so the current cannot flow. Okay, so the current is flowing only because of that there is a load, and it returns to its source. That's what we mean by a load. And a load types, how the load can be of type resistive only, capacitive, inductive, or a mixed. So when we talk about the loading, it can be only a resistor, a capacitor, inductor, or a mix of all those components or features in a particular load. Okay, so let's carry on. So in this particular slide, it's showing what is potential difference, which implies the voltage source. The voltage source can be considered as a pump supplying electrons to the load and recycles the excess electrons. So as you can see, it's like a hand pump. It's just like a basic, just to have a basic understanding that a pump basically water comes out, but you think this pump as that when you hand pump, the electrons come out and go through the load and return to its source. I think the better example, as I showed you, if you throw the ball up in the air, it comes back. So you can think that is as because of gravity and potential difference with respect to ground. Okay, let's carry on to the next slide. As mentioned before, the preliminary course requirements on this particular course is the high school, college, decent knowledge of mathematics and physics. Completion of your high school can really help you complete this course, and will really help you in your university, college, or private education, and give you in a kind of a strong footing in making decisions towards your career. Or if you're thinking of switching your career and getting into this particular area, it's also a very good course for you to take. Let's carry on. Okay. Again, any information, any questions you have, please send us an email to info@hsclouds, humanitiesservingclouds.org, or softgalaxy.hsclouds@gmail.com. Thank you, and we will see you in our next session. Take care.